In this video, we're going to discuss being able to take a derivative using something called the product rule. By the end of the video, you'll be able to find the derivative of a function using the product rule. The product rule is a necessary tool to being able to find a derivative when the function that we're trying to take the derivative of is actually two different functions being multiplied together. Notice here you have a multiplication symbol, and you have two different functions that are being multiplied together. In the next slide, you're going to see an example so you'll get a better idea of this. But the way that we find the derivative of a function that has a product in it is something like this. Now what this says is our f function is the first function, our g is the second. And the way to think about this is that this is 1 d2. So f of x is the first function, g prime of x is the derivative of the second, plus 2 d1. 2 being the second function, g of x, d1 being the derivative of the first function, f. Let's take a look at an example and see how do we apply this 1d2 plus 2d1 idea of the product rule. Here's a function. The function is, as you can see, a product of two different things. It's 3x minus 2 times the quantity of 2x plus 5. Now, you can use some of the other rules that we've learned. For example, I could rewrite this function using the FOIL method and get 6x squared plus 15x minus 4x minus 10. Rewrite that one more time to get 6x squared plus 11x minus 10. And now I can very easily use power rule to take my derivative to get 12x plus 11. This is the derivative. There's no debating that. This function will only have one derivative. However, sometimes we're going to run into functions where I couldn't use the FOIL method to get back to a polynomial and then use power rule. So we need to be able to use and apply the product rule to see how this would work. In the product rule, think of what we need. We have the idea that there's two functions that are being multiplied together. Here's my first function, 3x minus 2. Here's my second function, the 2x plus 5. So using the product rule, my derivative is going to be 1, my first function, 3x minus 2, times derivative of 2. So 1d2. Derivative of 2x is 2. Derivative of 5 is 0. So the derivative of 2x plus 5 is just 2. Here's 1d2. Then I need to do plus 2, my second function, 2x plus 5, d1. The derivative of 3x is 3, derivative of negative 2 is 0, and that goes away. So again, we have 1 d2 plus 2 d1. Now, in order to make sense of this and make sure that we can see that these are in fact the same thing, all I'm going to do is distribute out this idea. I'm going to multiply my 2 by both pieces and get 6x minus 4. I'm going to distribute this 3 to both pieces and get plus 6x plus 15. And notice when I simplify this, I get my derivative to be the exact same thing. 6x plus 6x is 12x. Negative 4 plus 15 gives me positive 11. Either way I found the derivative of this function, I was able to get to the same idea. The derivative of that function is 12x plus 11. Now, why do we need product rule? The reason why we need to know product rule is because sometimes we're going to run into functions that you can't multiply out to a polynomial and use power rule. In this function, we had options. We were able to do it in either way. Take a look at a new example. Now if my function was 3x squared times cosine of x, I can't use power rule. This time I have to use product rule and be able to apply it. So notice this function is really two different functions that are being multiplied together. My first being the 3x squared, my second being the cosine of x. This we'll call our first function, this we'll call our second function. So to find the derivative of this function using product rule, we apply our 1d2 plus 2d1 idea. So our derivative, f prime of x, is equal to 1, 3x squared, times the derivative of the second part. So cosine of x is my second. Derivative of that is negative sine x. So there's 1 d2 plus 2 cosine of x times the derivative of the first part. Derivative of 3x squared is 6x. This is our derivative. Now it's up to you if you want to take this one step further and rearrange some of these pieces to make it look prettier. That's completely up to you. I understand what these are. A 3x squared times a negative sine x, we can rewrite as negative 3x squared sine x. Cosine plus 6x, we would want to write the 6x in front if we were rearranging it. Either one of these would be an acceptable answer. But again, notice how we had to use product rule in order to be able to find the derivative of this function, 3x squared times the cosine of x. So hopefully you get a little idea of how the product rule works. I'd like you to try the product rule for these three functions. Now would be a time where you're going to press pause. After you've found the derivative for these three, unpause, come back, and check to see how you did. So take a look at that first one, f of x. We were trying to find the derivative of the quantity 2x cubed minus 3x times the quantity x squared minus 5. And I did this using the product rule instead of foiling that out, which I could have, because I'd FOIL it out to a polynomial. But notice using the product rule what I get. Here's my 1, my first function, times the derivative of the second part, plus 2, my second part, times the derivative of the first. Now, for our purposes of what we want, you can leave your answer just like this. I will understand what it says here. The only reason why we would ever want to simplify this is if I asked you to do more with this. Right now, all I'm asking you to do is find the derivative. And remember, all the derivative is a new function that describes the slope of the tangent line. This describes the slope of the tangent line. If I wanted to know what the slope of the tangent line when x equaled 0, I'm just going to still plug 0 in for x. We would just be able to simplify that, no matter if it was simplified more or not. Let's take a look at the next example. So here's my two pieces, sine of x and cosine of x, my 1 and my 2. So the derivative, g prime of x, would be 1 d2 plus 2 d1. And notice from here, we can simplify this, and this is very easy. I don't have to, but I can notice that sine of x times negative sine of x is just going to give me negative sine squared of x plus cosine squared of x. This right here is our derivative, g prime of x. Hopefully that's what you got. Let's take a look at the third example. So here's the derivative of our third. We've got our two pieces, our products, our first part and our second part that are being multiplied together, indicating that we should use the product rule in order to find the derivative. So here's my 1 d2 plus 2 d1 idea. And again, we don't have to simplify this right at this second, unless I was being asked to do something further with it. In order to just find the derivative, this would be a perfectly acceptable answer. So here we are at the end of the video. Now you should be able to use the product rule in order to find the derivative of a function that has a product in it.